Okay, I hope I'm audible to all the students who are attending this lecture. We start with a new topic in class 12 mathematics. This is called application of integrals. In the last few lectures, we were practicing questions on integrals. In this lecture, we start with a new topic. Okay, this is called application of integrals. So basically in this chapter we'll be looking at whatever integration problems we have done before, how can we apply them to various problems. Okay, so basically the first application of integrals which is in our course, this is called area under simple curves. Area under the simple curves. So the concept of integrals is used to find area under a curve. So let's understand this through a diagram. Suppose we have the y-axis and the x-axis. Okay, this is our origin. And suppose this is my curve. You can see I've drawn a curve y equal to f of x. Suppose this is my curve y equal to f of x. I need to find the area. This is x particularly taking the value a. This is x taking the value b. And I need to find this area. This whole shaded area in red. So basically, I need to find the area under the curve y equal to f of x from x equal to a to x equal to b. Okay, so I need to find this red shaded area. Let me call this as capital A. This is the area. So how will I find this area? This area A will be nothing but integral from x equal to a to x equal to b. We are integrating the function f of x with respect to x. Okay, so if I need to find this red shaded area, it will be integral from a to b, the function f of x with respect to, we are integrating it with respect to x. So I hope that is clear to all the students. Okay, similarly, I can draw another diagram. So you can clearly see this is another case. Look at this diagram now, which I am drawing on the screen on the right hand side. Suppose, guys, again, this is my x-axis, this is my y-axis. And suppose we have a function like this. And this is x as a function of y. Okay, this was the first case where y is a function of x. This is the second case where x is a function of y. And guys, suppose this is my y equal to a. And suppose this is the line y equal to b. Okay, y equal to a and y equal to b. And guys, suppose we need to find this area. Again, you can see the red shaded area on the right hand side of the diagram. Suppose I need to find this area. Now again, this is area under the curve g of y as y goes from a to b. So what will my area be? So this is my area A. So A here is nothing but integral. As y goes from a to b, we are integrating the function g of y with respect to y. So g of y dy. That means now we are integrating the function g of y with respect to y as y goes from a to b. Clear? So I hope all students attending the lecture have understood diagram 1 and diagram 2. In diagram 1, y is a function of x. We need to find the area. This is the formula we applied. we will integrate the function f of x with respect to x, running it from a to b. In diagram 2, we have x as a function of y. So we will integrate g of y with respect to y, running it from a to b. I hope that is clear. And I can draw one more diagram. Suppose, guys, we have the area which is in the negative axis. So till now we only looked at the positive axis, but let's consider the possibility that we need to find the area in case of a negative axis. So suppose my curve is like this. Suppose this is my curve y equal to f of x. This is the origin. And guys, suppose this is x equal to a and this is x equal to b. You can clearly see now the area is coming in the negative axis. Suppose I need to find this shaded area. Okay, I need to find this shaded area. You can clearly see now the function is in the negative axis. So guys, in this case, my area will be, now all of us know area can never be negative. So it will be modulus of integral as x goes from a to b. We integrate the function f of x with respect to x. So in this case, we will be taking the absolute value or the mod value, because area can never be negative. So I hope all students have understood the basic underlying theory behind the area under a simple curve. Okay, so now we can do some practice questions based on it. So practice questions based on area under the simple curves. Okay, so let's look at these practice questions one by one. Question 1. Find the area enclosed by the circle whose equation is given by x square plus y square is equal to a square. Okay, so this is the circle given to us. All of us know that x square plus y square equal to a square is the equation of the circle with the center at 0, 0 and the radius given by, what is the radius, guys? The radius is a. From class 11th mathematics, you can recall that this is the equation of a circle. X minus alpha square plus y minus beta square equal to r square is the standard equation of a circle. You can recall this from class 11th mathematics chapter conic sections. Okay, the center of this circle is alpha comma beta and the radius of this circle is r. So if I compare this with this, the center is at the origin 0, 0 and the radius is a. So can we draw a diagram? Let's draw a rough sketch of this, because the diagram will indicate what is the area we need to find. So x-axis, y-axis, you can see I'm drawing a circle. It is centered at 0, 0 and this is a comma 0, this is 0 comma a, this is minus a comma 0 and this is 0 comma minus a. So guys, we need to find this area. So now basically we need to find the whole area of the circle. That means we need to basically find this whole area. Now we can do one thing. We can find this red shaded area and we can multiply it by 4, right? what I'm planning to do, or what even NCRT does, is that your NCRT finds this area. So we can find this red shaded area, because all of us know they are all symmetric. So if I find this red shaded area and if I multiply it by 4, I will get the area of the whole circle, right? So let's find this red shaded area now. So how will I find this red shaded area? You can clearly see that this is nothing but, so area of the red shaded region, is integral. Okay, we can integrate with respect to x. So guys, x is going from 0 to a. So as x goes from 0 to a, we are integrating with respect to x. Now guys, how will I find x? So look at the equation. X square plus y square equal to a square. So I can write, what is my y square? A square minus x square, which implies my y is nothing but under root of a square minus x square. It's plus minus, but we will consider the positive part because we are in the first quadrant. So our y is positive. Okay, so see what I am doing. I am integrating with respect to x. So since we are integrating with respect to x, our term should be in terms of x. Now we are given the equation x square plus y square equal to a square. How can I write this in terms of x? Y square is equal to a square minus x square. So y is equal to plus minus under root a square minus x square. Now I will not consider the minus part because we are in the first quadrant. So I will take under root a square minus x square times dx. Now all students should be able to recall from the integration lecture that integral of under root a square minus x square times dx is equal to x by 2 into under root a square minus x square plus a by 2 into sine inverse x by a. Recall this formula from the integration lectures. Okay, so if I apply this formula here, it becomes x by 2 into under root a square minus x square plus a by 2 sine inverse x by a. And guys, I run this from 0 to a. So if you put a in the expression, a by 2 into under root a square minus a square, it anyways becomes 0, plus a by 2 into sine inverse of a by a becomes 1. And if I put 0 in the expression, everything anyways becomes 0. So guys, I get a by 2 into sine inverse of 1 is pi by 2. So what do I get? Area of this red shaded region. So I can erase some part and I can write. So I'm erasing the initial part. All of you know it's the circle. All of you know that it's the circle. So I'm erasing the initial part and I'm continuing. So guys, area of the red shaded region is how much? It is a by 2 into pi by 2, which is a pi by 4. Therefore, area of the whole circle. How will I find this? What will area of the whole circle be? So area of the whole circle will be multiplied by 4 simply. If you look at the area, guys, there's one more thing. This is a square by 2 sine inverse x by a. Let me correct it. This is a square by 2. So this is a square by 2 sine inverse. So this is a square by, this is a square pi by 4. Please correct it. Integral of under root a square minus x square dx is x by 2 into square root of a square minus x square plus a square by 2 sine inverse x by. So area of the whole circle will be 4 times the area of the red shaded region, which means 4 into a square pi by 4, which is nothing but a square pi. So this will be the area of the whole circle. So this is my final answer. So I hope students have understood how we have solved this question. We have used the concept of integration. We draw a rough sketch of it. It is a circle. We find the area of the first quadrant, the red shaded region, and we multiply it by 4 to get the area of the whole circle. And how do we find the area? Suppose we are integrating with respect to x. You can integrate with respect to y also. Suppose I'm integrating with respect to x, then you can see that x is running from 0 to a. In the picture, you can see x is going from 0 to a. So from 0 to a, I need to integrate x. So this is the circle given to us. Can I write this in terms of x? So y square is equal to a square minus x square. So y is equal to square root of a square minus x square. Integration of this is this. I run this from 0 to a. I get a square pi by 4 to get the area of the whole circle. Multiply by 4, I get the required answer. Okay, now let's look at the second question. Let's look at the second question. So this is question 2. Find the area enclosed by the ellipse x square by a plus y square by x square by a square plus y square by b square equal to 1. Okay, now all students have done the concept of ellipse in conic sections chapter in class 11th mathematics. Okay, so if you plot the ellipse, how will the ellipse look like? So in this, our major axis is the x-axis. All of you should remember that in case of an ellipse, you have the major axis and the minor axis. Clearly, x-axis is the major axis here. Y-axis is the minor axis. This is how an ellipse looks like, guys. You can please revise your class 11th mathematics conic sections lecture. That will give you an idea about how the ellipse looks like. So this is a comma 0. This point is minus a comma 0. Basically, you put y as 0 here. So x square is equal to a square, which means x is plus minus a. And if I put x as 0 in this equation, y square is equal to b square, which implies y is plus minus b. So guys, this is 0 comma b. This is 0 comma minus b. This is my ellipse, and basically I need to find this whole area. So again, guys, what we can do, the same thing which we had done in circles. Let me find the area of this red shaded region and multiply it by 4. So again, we are going to find the area of this red shaded region. This is the first quadrant. In the first quadrant, both x and y are positive. We find the area of this red shaded region and then we multiply it by 4. So see, what are we doing? So area of the red shaded region, will be, suppose I am integrating with respect to x. So this is my origin, 0 comma 0. So x is going from 0 to a dx. And now I have to write this equation in terms of x. Can I write this equation in terms of x? So guys, x square by a square plus y square by b square is equal to 1. So y square by b square is equal to 1 minus x square by a square. So this implies y square by b square is equal to a square minus x square by a square. So guys, my y square will be b square by a square into a square minus x square, which implies my y will be b by a into under root a square minus x square. That means if I am integrating with respect to x, I have written y in terms of x. So I can write here b by a times under root a square minus x square. Guys, again, I have not taken the negative sign of y because we are in the first quadrant. And in the first quadrant, x and y both are positive. So this is the area of the red shaded region. We are integrating with respect to x. Now, since we are integrating with respect to x, x is going from 0 to a. And we have written the equation of the ellipse in terms of x. So y is equal to b by a into under root a square minus x square. Now all I have to do is integrate this. So I am erasing all this part. All I have to do now is to integrate this. So let's integrate this just as the way we have learned in the integration lectures. So guys, b by a is a constant. It comes out into integral from 0 to a under root a square minus x square times dx. And we have seen that what is the integral of this? It is x by 2 into under root a square minus x square plus a square by 2 into sine inverse of x by a, which we run from 0 to a. Okay, so we have just done that integral of a square minus x square is this. Okay, now I can plug it. So I first put a. So a by 2 into under root a square minus a square becomes 0 plus a square by 2 into sine inverse of a by a becomes 1. And guys, if I put 0 in the expression, everything anyways becomes 0. So my red shaded region area is b by a into a square by 2. Sine inverse of 1 is pi by 2. So this becomes b pi by 4 or b pi a by 4. It becomes b pi a by 4. That means area of the red shaded region is finally b pi a by 4. So guys, area of the whole. So I can write area of the whole ellipse will be 4 times the area of the red shaded region, which is AB pi by 4. 4 and 4 cancel. My final answer is AB pi. This is my final answer. That means area of the red shaded region had come out as AB pi by 4. So area of the whole ellipse will be 4 times the area of the red shaded region, which is AB pi. So hoping that students have understood this and have no doubts in this question. Then we can quickly look at question 3. Now question 3 talks about both the curve and the line which is given to us. So let's see this question. Find the area of the region bounded by the curve y equal to x square and the line y equal to 4. Okay, so always in questions like these, step 1, you draw a rough sketch. You should draw a rough sketch, and you all should be comfortable with the chapter on conic sections which we had done in class 11th mathematics, because you can see now if you look at y equal to x square, guys, it's a parabola. Y equal to x square is a parabola. If you plot it, it is going to pass through the origin, because the origin is the vertex of this parabola. This is the parabola y equal to x square with the vertex at 0, 0. Again, where do you learn this? You learn this in conic sections lecture of class 11th mathematics. Y equal to x square is the equation of a parabola with vertex at 0, 0. And how do I plot the line y equal to 4? So y equal to 4 will be the brown line you can see on your screen. Y equal to 4. So guys, basically I need to find this area. We need to find the area bounded by the curve and the line y equal to 4. So this is the area I need to find. Clear? Now, let us first see with what are we integrating this with respect to. So in this case, you can see x, the origin is 0, 0. And if you look at this point is nothing but 0, 4. So we can integrate this with respect to y. So first you need to decide with what you need to integrate it. Now you can integrate this with respect to x also, but to do that you will need to find this point. Suppose you plan to integrate with respect to x, that is fine. But then you will need to find the point of intersection of y equal to x square and y equal to 4, which is time consuming. So that is why we are integrating with respect to y. So integral as y goes from 0 to 4 dy, and this is the curve given to us. We need to write this in terms of y. So guys, x square is equal to y. That means x is equal to plus minus root y. But will I take minus root y? No, because we are in the first quadrant. Now in the first quadrant, x is equal to root y. So guys, I can write root y times dy. Now all of us know y to the power half by integral is y to the power half plus 1, which is 3 by 2 into 2 by 3. I run this from 0 to 4. This is 2 by 3 into 4 to the power 3 by 2. If I put 0, answer is anyway 0. So this is 2 by 3 into 4 to the power half is 8. Sorry, 4 to the power half is 2 and 2 ka cube is 8. So my answer will be 16 by 3. Our answer will be 16 by 3. Okay, so 1 minute. Let's check this up first. Okay, so guys, we need to find this part also. We need to find this part also. We need to find this whole area. So what I've done, you find basically you if you look at it, guys, we need to find all this area. So I am drawing the parabola once again. And basically we need to find this whole area. The area bounded by the curve and the line y equal to 4 is this whole dark shaded area. So what I have done, we have first found the area of the red shaded region. So area of the red shaded region. Area of the red shaded region is 16 by 3. So area of the whole region is 2 times the area of the red shaded region. So my answer is 32 by 3. This is our final answer. Guys, the red shaded region has an area of 16 by 3. We need to find the area of this whole dark shaded region. So this will be 2 times the area of the red shaded region, which is 2 times 16 by 3, which is 32 by 3. So again, hoping that all students have understood this and you are clear with this. Now we move forward to the next question, question 4. So find the area of the region in the first quadrant. Find the area of the region in the first quadrant enclosed by the x-axis and the line y equal to x and the circle x square plus y square equal to 32. So we have 3 things here. Okay, First of all, you should know x square plus y square equal to 32 is the equation of a circle with center at 0, 0. And what's the radius, guys? The radius of the circle is root of 32, 0, and root of 32 is nothing but 4 root 2, 0. So if you plot the diagram, see the diagram we are drawing, x-axis, y-axis. You can see the circle I've drawn. Origin is at 0, 0. This is 4 root 2, 0. They are asking us only the first quadrant and the line y equal to x. Now, guys, the line y equal to x, you can see in brown color. This is the line y equal to x. So see, it has to be the first quadrant. It has to be the line y equal to x and the circle. That means if you look at it, we need to find this area. This is the red shaded area which we need to find. It is the area enclosed by the line y equal to x, the circle, and the first quadrant. Now, how do I find this area? First of all, you can see that we need to find with what we need to integrate. Do we need to integrate with respect to x or with respect to y? You can clearly see that we need to find this area. So we will be integrating with respect to x as x goes from 0 to 4 root 2. Now look at it, guys. We can find this area, but look at what I am doing. First of all, I am drawing a perpendicular. You can see the perpendicular, the dark perpendicular I am drawing. Okay, so this is my region 1 and this is my region 2. You can clearly see on the screen I have drawn a perpendicular and the whole area. So I can say my required area is equal to area of region 1 plus the area of region 2. You can clearly see in Roman numerals I have marked region 1 and region 2 on the screen. Now, first of all, let us find this point of intersection. What will this point be? So y equal to x and x square plus y square equal to 32. So I can put y equal to x in this equation. So it becomes x square plus x square equal to 32, which implies 2x square is 32, which implies x square is 16, which implies x is plus minus 4. Now x equal to minus 4 is rejected. Why? Because the question clearly says that we are in the first quadrant. So therefore, guys, my x is equal to 4. If x is equal to 4 and y is equal to x, y is also equal to 4. That means, guys, the point of intersection of the circle and the line is nothing but 4, 4. So now our job is to integrate in such a way so that we first find the area of region 1, then we find the area of region 2. So guys, what will this point be? So basically this is my region 1 and this is my region 2. Now this point will be how much? It will be 4, 0. Because this point is 4, 4. If I drop it to the x-axis, it is 4, 0. So guys, let's now find the area of region 1 and region 2. So let's find that. So it's a very good question. We can find the area of region 1. So this is how we find it. Area of region 1 will be, as x goes from 0 to 4, we are integrating with respect to x. And what are we integrating? We are integrating the line. Remember guys, in region 1, we don't have the circle coming up as of now. In region 1, you only have this line and you have the horizontal axis in region 1. So as x goes from 0 to 4, what is my line? Y equal to x. If I write it in terms of x, it's nothing but x dx. Clear? Now, if I integrate this with respect to x, I get x square by 2 and I run this from 0 to 4. So it is 4 ka square by 2, which is 16 by 2, which is 8. That means, guys, area of region 1 is equal to 8. Very simple. We have integrated this from 0 to 4. I repeat, we have integrated this from 0 to 4. What have we integrated? The line. So we have integrated the line y equal to x from 0 to 4. And y equal to x means x dx, basically. Okay. Now our job is to find area of region 2. Our job is to find the area of region 2. So how will I find area of region 2? Now you can see in case of region 2, my x is going from 4 to 4 root 2. Closely look at region 2. My x is running from 4 to 4 root 2. In region 1, x was running from 0 to 4. In region 2, x is running from 4 to 4 root 2. And what is the curve? Now we have the circle. In region 2, you can see we are having the circle now. So circle is x square plus y square equal to 32. I need to integrate with respect to x. I write this equation in terms of x. So y square is equal to 32 minus x square. So y will be square root of 32 minus x square. So this I can write under root 32 minus x square. Clear? This is how I can write it. So now if I integrate it, all of you know under root a square minus x square ka integral. So this is half x into under root a square minus x square plus, then what does it become? So guys, if you look at the integral formula, I'm writing it on the top for reference also. So the formula was integral under root a square minus x square dx is x by 2 into under root a square minus x square plus a square by 2 sine inverse x by a. So if I apply this formula here, it is as follows: x by 2, let me correct it. Yeah, it is x by 2 into under root a square minus x square. A square is 32 plus a square by 2 times sine inverse of x by, guys, how much is a? Now a square is 32. A square is 32. So your a is 4 root 2. So sine inverse of x by 4 root 2. So you can see, guys, this formula I have applied here. X by 2 into under root 32 minus x square plus a square by 2. A square is 32. So 32 by 2 sine inverse x by 2. And now I run this from 4 to 4 root 2. So if you put it in the expression, let us see what do we get. So I can put everything in the expression now. So if I put 4 root 2, this is 4 root 2 by 2 into under root. So guys, we will be needing some space. So what I'm doing is, let me erase the initial part. Let me erase all this. Okay, so if we further solve this up here, it becomes, so I'm solving it here on the top. So if I put 4 root 2, It's 4 root 2 by 2 into under root 32 minus 4 root 2 ka square, which is again 32, becomes 0, plus 32 by 2 into sine inverse of 4 root 2 by 4 root 2 is 1, minus, if I put now 4 in the expression, 4 by 2 into under root 32 minus 16 plus 32 by 2 into sine inverse of, if I put 4 here, it becomes 1 upon root 2. So guys, now you can solve this at home. It's not tough to solve. If you solve it at home, you get your answer as 8 plus 4 pi. So I can write area of region 2 is nothing but 8 plus 4 pi. Basically, if you solve this expression, you will get your answer as 8 plus 4 pi. So now what will my required area be? Area of region 1 is 8 plus area of region 2 has come out as 8 plus 4 pi. Okay, area of region 2 has come out as 8 plus 4 pi. So 1 minute, guys, your answer will not come as 8 plus 4 pi. Your answer will come out for region 2 as 4 pi minus 8. Area of region 2 when you solve this expression comes out as 4 pi minus 8. Please correct. For region 1, the area is 8. For region 2, when you solve this whole expression, you will get the answer as 4 pi minus 8. So your required area will be 8 plus 4 pi minus 8, which is nothing but 4 pi. 4 pi is your final answer. So the required area is 4 times pi. So I hope all students have understood this question. Area of the whole region is 4 times pi. So first we find the area of region 1 where x goes from 0 to 4. We integrate x dx, and then we find the area of region 2 where x goes from 4 to 4 root 2, and the area of region 2 comes out as 4 pi minus 8. We add them up, we get the final answer. So hoping all students have understood this, and then we can do the last question for this lecture, after which I intend to stop. So let's look at this question. Question 5. Find the area bounded by the ellipse x square by a square plus y square by b square equal to 1, and the ordinates x equal to 0 and x equal to ae, where we are given that b square is equal to a square into 1 minus e square, and e is less than 1. Okay, so clearly guys, you can see that it's the equation of the ellipse. So if I draw a figure, we can first draw a figure for the ellipse and see how it looks like. X-axis, y-axis. This is my ellipse. Okay, and now x equal to 0 means the y-axis only, and x equal to ae. How do I plot x equal to ae? It's the brown line you can see. This is my line x equal to ae. This is the origin, guys. This is x equal to ae, so this is ae comma 0. Correct? This is my line x equal to ae. It cuts the x-axis at ae comma 0. X equal to 0 means the y-axis. So basically we need to find what area? Basically we need to find this whole area. we need to find this whole area. Area bounded by the ellipse, x equal to 0 and x equal to AE line. So guys, see what I am doing. First, I am finding this red area and then I'll multiply it by 2. Right? So area of the red shaded region. Area of the red shade region is, we are integrating with respect to x. So x is going from 0 to AE. With respect to x, we are integrating. So guys, this equation, if you write in terms of x, how will it look like? B by A into under root A square minus x square. Correct? This equation, if you write in terms of x, it looks like this. Now guys, b by a as a constant comes out into integral a square minus x square as x goes from 0 to AE. So guys, if I integrate it, all of us know the integration of this now. X by 2 into under root a square minus x square plus a square by 2 sine inverse x by a. We run this from 0 to AE. So guys, in this expression, if I put AE, so I get B by A into AE by 2 under root A square minus A square E square plus A square by 2 into sine inverse of AE divided by A is E. Okay. And if I put 0, everything becomes anyway 0. So if you look at it, it becomes if I further evaluate it, if I open up the brackets basically, so it becomes BE by 2 times under root A square minus A square E square plus AB by 2 times sine inverse E. So this is the area of the red shaded region. This is the area of the red shade region, but now our job is to find the area of the whole region. We have just found the area of the red shaded region, but we need to find now the area of the whole region, the whole black shaded region. That means guys, we need to find this whole area. Ultimately, we need to find this whole area. So required area will be 2 times the area of the red shaded region, 2 times the area of the red shade region, which is 2 times BE by 2 into under root. I can take A square common, so it becomes 1 minus E square plus AB by 2 times sine inverse E. So it becomes BE ABE into under root 1 minus E square. I am just opening up the brackets here. And in this, I can take AB common. So becomes E into under root 1 minus E square plus sine inverse. This is the final answer for this question. Final answer for this question. So I hope all students have understood this practice question. So guys, this is where I intend to stop in this lecture. What I've primarily covered in this lecture is area under the simple curve, where we have applied the concept of integration, and we have done 5 good practice questions on this. So I hope all students have enjoyed this lecture. Any doubt, you can unmute your mics and ask, or call up or mail me your doubts at divineschoolofeconomics@gmail.com. So this is where I